Welcome to an example in which we're looking at exponential growth and decay. This one says a population numbers 15,000 organisms initially, like at the start, and decreases, goes down by 3.8% each year. And then they mentioned an exponential model. Well, that's exactly right. So an exponential is when a population goes up or down by the same percentage, a fixed, let's say a fixed, it doesn't change. It's a fixed percentage each period of time, like each year, each day, each week, each month, whatever the period of time may be, when it just continuously goes up or down by the same percent each period of time. That's exponential. That's exponential growth or decay. So what do we do about that? Well, if we go up here to the notes, so here's the class notes. I'm expressing it right here. I say exponential growth or decay, definite time period, risk continues. I'm giving you two options. Basically, definite time period, that's what we have in this example. Like a substance decays by 5% per year. Then you use the formula A equals P 1 plus R to the T, and I'll show more of that in a second. The second option is if they don't give a definite time period. They just say, look, the substance decays exponentially. They don't say like every, 5% every week or 3% every year or whatever. It just says exponentially or continuously. In that case, you use the formula A equals P e to the RT. That's not our situation right now. So we're up here on number one. We have this formula we're going to use because they're giving us a fixed percentage and a time period, right? They're saying 3.8% each year. So when they say that, you use A equals P 1 plus R to the T. And then notice you take that 5% and you plug it in for the R. It's the R, goes right there. And if it's decay, it's negative because decay goes down, right? Decay means something's going down. Growth is positive. In this case, it's decreasing. So I'm going to write the formula A equals P 1 plus R to the T. I know you might be thinking, well, there's a P out there, return, you're putting A. Yeah, it doesn't matter. It's just different authors use different letters at different times. Don't let that bug you. It's just it's the right setup. See, it's this kind of setup. It might look different to you, but see, it's something in the front and then a second letter to the T power. We have something in the front, then this whole thing to the T power. So we're on the right track. All right. So again, 1 plus, now you grab the R right here, this 3.8%, 3.8%. Remember what happens when you have a percentage, we need to change to decimal. It goes back 1, 2 places. So it's going to bring in a 0 right there. So it's going to be 0.038. And then that goes right there, 0.038 to the T. Is that making sense so far? I'm hoping. So again, I take the 3.8%. I take that decimal and I go bonk, bonk, back 2 places, 0.038. Why? Because I'm getting rid of the percent. I'm changing from percent to decimal. So first thing, I take that percent, move it back 2 places to make it a decimal, then plug it in for it's the rate. It's how and it's decreasing. Oh, yes, I should make that negative, huh? So this should be 1 minus because it's decreasing. So it's negative because it's decreasing. It'll be a negative 3.038, right? So decreasing, right there. It's decreasing. So that's why we have the negative. They're saying the amount, like the little organisms are dying off. The number is going down. It's decreasing, negative. The R is negative. If it was increasing, then that would be positive. So, and now what's the P? The P is the initial amount. Let me put that right there. And that is the 15,000. So, a little bit. So 15,000. So this is the initial amount, 15,000. Okay, so what do we have now? Now we have 15,000 in the front, and now let's subtract these on your calculator. You'll get 0.962 to the T, and that's our answer. And notice it's in the right format. What format? Well, they want us to go A, B to the T. This is the A, and this is the B. See how we've got that now? We've got a first thing and a second thing to the T power. That's what they wanted. They said, can be written in the form AB to the T. So one thing times the second thing to the T. So how do we do that? So again, when they give you that something's going up or down, increasing or decreasing by a fixed percentage each period of time, you write the formula A equals P1 plus R to the T. It's in the notes. And then the R is the rate. That's 3.8%. Take that, make it a decimal, move it back 2 places. It's negative because it's decreasing. If it was increasing, it'd be positive. Plug that in there for R, negative, decreasing, 0.038. Then just subtract those in your calculator, 0.962. And what goes in the front is the initial amount. 15,000 is initially. That's in the front. And there we go. There's our answer. That's what you put in the box right here. And that's how we handle exponential growth and decay.